The calculator part can be very easy to get right. It can also be very easy to get wrong because you're in the wrong mode, everything's wrong. You forget a parenthesis, it's wrong. You type the wrong number, it's wrong. You don't know the difference between X and Y. Okay, but if you know all of those things, which you should know, then it can be very easy to get this part correct. Now, this is not on your quiz tomorrow, so this worksheet's not due till Wednesday, even though it says Friday. It's a typo. It means Wednesday, the 5th. Okay, the problems for today. So your quiz tomorrow does not cover this section. All right, so first, the directions. You have to know what the directions mean. If you don't read the directions, then you might not even answer the question correctly. So it says, for numbers 1 and 2, find f of x for the given value of x. So if they give you x, then obviously you know x. So your answer is going to be the y value. So here's an x, what's y? Plug it in. If it gives you the f of x, which is another way of writing y, just function notation of y, then it gives you the y. You have to find all the x's, because remember it's a sinusoid. It's going to snake for the left and to the left and the right forever, so you have to find those answers. So this first one you can do a lot of different ways. You could just plug it into your blank screen. You can go to y equals. I'm going to do y equals every time, just because in a minute the problems get really ugly and you don't want to type those in 3 or 4 times. You want to type it in once and then just use that every time. So if I go to y equals, well, first let's look at the mode. It says use degrees. My calculator was cleared, so I need to change it to degree mode. That's the first thing. Then I'm going to go to y equals and just type in sine x. Now, because it's f of 3, that's easy. The table can give me anything. You can go to the table straight from second graph, and it gives you all those values. Now, let's say it was 3.7. Well, 3.7 isn't in that graph. So I could go to the blank screen and say sine of 3.7. I could go to my table set, start it at 3.7. I could ask at 3.7 and go to the table. All kinds of different ways to do that. It's up to you. However you learned it, you can do that. You can start your table wherever you want. If I wanted f of 5,321, I wouldn't want to scroll 5,321 times on my table. I can either plug it in or go to the blank screen and plug it in. All right, so because it's 3, I just like to look at the table. So I look down at 3. Here's my y value. I always round to the thousandth, so that is 0.052. There's your answer. Should there be a degree sign on that answer? No. Where's the only place degree signs ever will be? On the x value. Is this an x value? No, this is the y value. Y values are a value always. The x-axis is the only place that could be degrees or radians. So it's just 0.052. If I were to just hit sine 3, enter, I get the exact same answer, as long as you're in the right mode. If you're not in the right mode, you're not going to get the right answer. All right, now this other question tells me it's not going to be the same. It's a different question. It gives me answers in a different way, so I have to work it differently. F of x equals 0.76. So it's telling me the function. I want to know when the function sine of x equals 0.76. Well, we just got finished doing sine of x equals 1/2, and we could do that without a calculator because we just looked on our unit circle, the 2 places it happened, wrote our general solutions, figured out the answers on a domain or first 3 positive, whatever the question was. But here we can't do that. So this is where we plug this into y1 or y2. It doesn't matter. It's already in y1. We plug this into y2, and we want to figure out where they're equal. So if you want to figure out where 2 graphs are equal, where do they cross? Well, let's graph it. Well, it looks like my calculator is broken because it did something right here, but then it drew this straight line. So my calculator's broken. What do? No, your calculator's not broken. Okay? 18 years, nobody's calculator has ever not graphed what they put in it. Okay? So we have to think about this. This is in degrees. One cycle, just one cycle, is 0 to 360. Right now, Our blank screen is negative 10 to 10, so it's only showing 20 degrees out of 360 degrees. So it's not going to show anything. It's going to look like something's wrong. So we can do a couple different things. We could get the calculator to get us on the right track. So if I look at Zoom, trig, that's what I'm doing, trig, and it knows what mode I'm in. So if I hit Zoom 7, it's going to adjust the window for me. Now, maybe we like that window, maybe we don't. It's up to you. If you know what that graph means from that point, you can. Remember, it goes on and on forever. Now, since I'm looking for general solutions, I want to know how many solutions there are per period. So I'm going to adjust my window a little bit more, and I just want to see one period on my graph. Well, sine of x, one period, is 360 degrees. So I'm going to make my x min 0, my x max 360. Not because I have to, but just because I'm not sure, I don't know how many solutions to write. I know for sure if I graph one cycle, I see how many times that line, 0.76, crosses, I know. So I'm going to have two solutions. After that, they're just going to repeat, plus the period. So x equals, I find these 2 points of intersection. So second trace 5. Now I like to travel in a straight line, gets me there quicker. So if you hit the up or down arrow, notice it goes from one graph to the other. That's how you get from one graph to the other. I want to find that first one first. Doesn't matter which one you find first. Enter, enter, enter. And there's the first time the sine graphs, or a time. Not necessarily it's the first positive, but it's a time it crosses. So x equals, now we're talking about our x value, so we do use degree symbols. 49.464 degrees plus the period, 360 degrees times n. Then I have this next one, second trace 5. Just do that again. Be sure you get closer to that point of intersection. Enter, enter, enter. X equals 130.536 degrees plus 360 degrees n. So there are your general solutions. Now, are those the only two you could have used? No, you could have used two negatives. You could have used two further down the road, wherever you wanted to find those two. After that, they're going to start repeating. That 49 plus the period is going to give us our third one in line to the right. 130 minus the period would give us our next one to the left. Okay, so we can add and subtract that period forever, because remember, n is an integer. Integers are positive and negative whole numbers. All right, the next one says use radians. Now, on these, your graph can look crazy. If you don't fix your window, either your graph will show you nothing, or earlier someone did not fix their graph and it showed them 120 cycles. So it basically looked like a bunch of scribble on their screen. So what I do is I just clear the RAM every time. So second plus 712. I'm just going to start from scratch each time. That way I don't have to worry about anything. You don't have to do that, but if you just go back to normal each time, it'll make it a lot easier. Again, not necessary, but it'll help you from seeing nothing or way too much most of the time. We're in radians, so when you clear it, defaults to radians. So my mode is in radians, but always check that. We want to know tangent of x. Now, we don't want to ever put tangent of 3 in the y equals. If we put tangent of 3 in the y equals, it's going to give us a horizontal line. We don't have any x values. If you expect to see some kind of function here other than a straight line, there needs to be a variable. If we put tangent of 3 in there, we would get a horizontal line at whatever tangent of 3 equals. So we put tangent of x. Always needs to be a variable unless you're looking for a horizontal line. And then we can go to our table, or we could have just gone to a blank screen and hit tan 3, enter. Both ways we would have got the same answer. So we look down there and we get negative 0.143. Or if you like to put that 0, negative 0.143. If you like to put that 0 there. I don't care if that 0 is there or not. It does not matter to me. All right, so that's easy. Plug it in. Especially this one, because if you could have just done tan 3 equals. If it's tan 3.1, tan 3.1 equals in your blank screen. Now, just like the previous, we want to know when does the function equal negative 0.15. So we want to know, oh, and all these should be the same variable. Either this should be tangent x or these should be thetas. Those can't ever be anything else. So tangent theta equals negative 0.15. Or you can change that theta to an x. Okay, just typo on there. All right, so y equals, we already have tan x in there, so we want to put in negative 0.15 and graph it. Now, if your graph doesn't look like this, that means you just didn't clear it out. It's in whatever mode that it was in from the previous problem, which is fine. Now, if you know what you're doing and you know that that negative 0.15 is a line that is very, very close to 0, and you just find your point of intersection, you can go from there. Notice this is a little different than sine and cosine. It's the exact same graph every period. So that's why tangents only have one general solution instead of two. Now, I'm going to do the same thing. I want to make sure I have all my general solutions. So I'm going to change my window to be 1 period. 1 period is 0 to pi for tangent. So I can go second pi. I can actually type pi in right there. And if I pressed enter, it would calculate what pi is. I'm going to try that again. So I just want to look and see how many general solutions there are in 1 period. And it still doesn't look like it's graphing negative 0.15. Negative 0.15 is just really, really close to 0, so it's blending in. For tangent? Nope, not for tangent. Tangent and cotangent, it is not 2 pi over b. It is pi or 180 over b. So what I'm going to do there, not because I have to, but I just like to see that line. I want to make sure I did it right, is instead of seeing 20 units right there, I just want to see 2. So I'm going to say negative 1 to 1. Because now that is going to show up. Instead of saying 20 right there, this being 20 to negative 20, now it's negative 1 to 1. And now I can see that line is there. Maybe you know that line is there. You don't have to do all that work. So I can see there's one general solution per period. So second, trace 5, enter, enter, enter. So there we have an answer. Theta equals, or if you change that theta to an x, x equals 2.993 plus the period. Very important that we remember. That was one of the main points of that packet, is to remember all that stuff from Unit 2. Long time ago, but you need to know that for this unit. All that stuff from that packet is coming back. You got to remember it. So you went to the middle? I went to the middle? No, I just graphed 1 period. Okay. And I know 1 period is pi. So I could have done like negative pi over 2 to pi over 2. I could have done pi to 2 pi. It doesn't matter. Now, this was my normal. This is where I started right here. That's what it looked like to begin with. Now, could I have just done second trace 5 and just enter, 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 and just wonder where it pops up? Absolutely, you could have done that. Whoops, hit enter too many times, it goes away. Enter. Now this one gave me that intersection right there. So it gave me an x value of negative 0.149. That's fine. Okay? Doesn't say anything about positive or negative here. If we take negative 0.149 and add pi, we're going to get 2.993. So it doesn't matter which point of intersection you find, but there is just one, because they repeat. You keep adding the period, you get pi, or you get the next one. Add the period, you get the next one. So remember, tangent and cotangent are a little bit different than sine and cosine, because their pictures look the same every time. So if we cut through it, it's the exact same distance every answer we get. Whereas sine and cosine, secant and cosecant go up and down, and every answer isn't the period apart. Every other answer is the period apart. All right, so now here's where we have the crazy ones. So this is where it's not fun to have to type that in over and over again. So I would always just use my y equals. Type it into y equals the first time, and then just use that. Not because you have to, but just makes it easier. This has 3 parts to it, A, B, and C. You can do them in any order. I would suggest doing A first and then B and then C, just because sometimes the order matters. In this one it doesn't. You could do any of those letters at any time you want. But I'm going to start with letter A. Letter A says find the first 3 positive values. We know we're going to have 3 answers, and we know they're going to all have a positive sign. For f of x, here's f of x equals 1. So we want to know, when does that function equal 1? So we're going to plug that function into y equals. We're going to make sure we're in the right mode, which there's no degree symbols. And this pi should give it away right there as well in your b value. So y equals -1 plus 3 cosine. Now, if you have the ability to make your pi over 3 look like that by hitting, is it alpha y equals? Do that. My calculator is a little bit older, so it doesn't let me do that. So I need to put that pi divided by 3 in its own set of parentheses. But if yours lets you put it as the fraction top over bottom, you don't need to do that. We do need to open a second set of parentheses, or regardless, this parenthesis does need to be there for you. X minus 0.7 close, close. And then in y2, we're going to put 1. Because we want to know, when does that function equal 1? Now, very important here. This is where it can be very easy or very easy to get them all wrong. If you use a minus instead of a negative right here, it's going to give you an error. You're going to have to know that. I'm not going to tell you, hey, you typed in a minus instead of a negative. If you type in a negative here, it's going to give you answers. They're going to all be wrong, because it's going to multiply x times -0.7 instead of x minus 0.7. So negative sign versus minus sign, be sure you know the difference. All right, we're going to graph that. Now, we want to know the first 3 positive values. Here, x is equal to 0. So x is positive to the right of that. So this point right here. Now, my calculator is kind of old, so the pixels aren't so great. Yours that are newer, you might be able to see very easily if that is or is not negative. I'm not sure. No need to contemplate for 10 minutes whether it is or isn't. Just find it. Second trace 5. Find that point right there. Enter, enter, enter. It's negative, not the first positive. So we go on to the next one. Second trace 5. Be sure to move it over. Enter, enter, enter. There's your first positive. X equals 1.503. Do that again. Second trace 5. Again, I want to travel on that straight line because I'll get there faster than a curved line. The up and the down arrow will go from one graph to the other. Enter, enter, enter. Oops, too many times. It goes away. Just do it again. 5.897. Now, for the third one, if you remember how you get the third one from our non-calculator, you just add the period to the first. What's the period on this one? 2 pi over b. So what does that come out to be? Correct. 6. Most common mistake, just think 2 pi and move on. It is not. B is not 1 in this one. So we could add, now let's think about that. Also, 1.503 plus 2 pi. I mean, we don't just know that off the top of our head, so you'd have to do that, but that's not even the case. Or, check it. Okay, so let's see if that is 1.503 plus 2 pi. You'll see that it's not, and you get 7.503, which is easy to do without the calculator. If it's just 6, we add 6 to that number. We could do that without the calculator. You can do the calculator, but you don't need it. So there's letter A. Again, that third one you can find by finding the intersection, or you know the third is the first plus the period. Either way will work. All right, now for write the general solutions. So the general solutions are going to be These two, see how these two these two we found, everything else is just going to repeat. It's going to keep repeating. So we don't even really need to do any work other than use those first two and add the period in. So 1.503 plus the period, we just found the period to be 6n. X equals 5.897 plus 6n. So there are your general solutions. If you had put 7.503 plus 6n, you would have been repeating this one, and we don't want to write repeating general solutions. Typically, for sine and cosine, secant and cosecant, there are 2. Tangent and cotangent, there are 1. Okay, on a normal, typical graph. If you have squares involved, that's when it doubles, stuff like that. And then the last part, find f of 1. Letter C, find f of 1. Well, we already have it in y equals, so just go to the graph. F of 1 equals 1.853. And there is that answer. So know the difference between it giving you x and it giving you y. If it gives you x, you just find the y value. If it gives you f of x, that's general solutions, first 3 positive, or over a domain that would be given, which is like the last 2 problems. Questions so far? All right. Find all the values on this domain. So we know it's in degrees because the domain is in degrees, and that gives us a C value right here, 3 degrees. So that also gives it away. It's in degrees. So if we did clear your calculator, be sure you put it back in degree mode. Now you can do this one a couple different ways. If you don't like that +7 right there and you want to move it over before you do anything, you can do that. You can always do some calculations before you put it in the calculator. If I subtract 7, 2.4. If I like that better, I can do that. You don't have to. But less parentheses to deal with on the left side, so it's not a bad idea. Again, if you don't, then it's okay. Even the next step, a couple different ways you can go about putting it in your calculator. We have to remember some things about secant. There is no secant button on our calculator. So what we have to remember is unit 1. Secant of an angle equals 1 over cosine of that angle. So we could change this to be 1 over cosine of theta plus 3 degrees equals 2.4. Or we could say cosine, like we did with the non-calculator problems, equals 1 over 2.4. Whichever one you like better. It's going to get you the same answer. Now the graphs are going to look different. 1 over cosine versus cosine, one's going to look like the parabola is kind of going up and down, and the other one's going to be a regular cosine graph. But both of those mean the same. Either we change this to 1 over cosine, or if we take the reciprocal of one side, we take the reciprocal of the other. Either way works. Do y'all want me to put the left side or the right side in the calculator? Left, because that's kind of uglier. So I'll show you what it looks like. All right, so we're in the right mode. Yep, we're in degree mode. So y equals 1 divided by cosine. We could go ahead and just use x plus 3. And then 2.4. And then graph it. So looks like I maybe did something wrong. Let's make sure that I have a variable. I do have a variable, but again, this is like that first one. A cycle is 360 degrees, and I'm only looking at -10 to 10. But I know what my window, instead of like going to my window and trying to change it, zoom trig, I can just go straight to the window. This is going to be domain, so my x min. This is going to be my x max. So, window. The lowest number I care about is negative 180. The highest number I care about is 360. And now I can graph that. And that's what it looks like. So between that domain, I'm going to have 1, 2, 3 answers. Now, if you'd put this one in, it's going to be a cosine graph. This is going to be, I don't know, wherever that's going to be. You're going to get the same answers. It's just going to look different. Now, this one's a little tricky sometimes with finding the zeros, because if you're not in the right place, it's going to kick you down to this bottom part where there aren't any answers. So you always want to have your cursor in the little parabola looking thing. Because if I do just second trace 5, enter, enter, enter like I do normally, it might give me an error. And it does, because I wasn't close enough. So second trace 5, whoops, 1, second trace 5. I want to find that cursor. Right now this tells me that it's at 90, negative 19, so it's down here, way down in quadrant 4 somewhere. So I'm going to hit the up arrow, and I want to just find this first one over here. It doesn't matter which one you find first. Be on the inside, enter, enter, enter. And there's one of your answers, negative 68.376 degrees. And again, I don't care. The only time I care about the order of the answers is the first 3 positive. Other than that, I don't care about the order. Do that again, second trace 5. How you go from one graph to the other is just the up or down arrow. There's your next answer, 62.376. And then we could add the period to this. This is the period apart. The period that's just going to keep happening over and over again. Or we can just find that intersection, second trace 5. Again, I want to travel on the straight line because straight lines are faster to get places. And I want to be sure that I'm on the inside of that so it doesn't kick me down to the bottom. Enter, enter, enter. 291.624 degrees. And there are all the answers on that interval. If you had taken negative 68 and added the 360, you would have gotten 291.624. So that's always a method also. Negative 68.376 plus the period, 360. There it is. And when you're adding an integer to something, does it matter that we rounded beforehand? No, because we're adding the integer. Because if we add an integer, those decimals are not going to change, 0.000, nothing's going to happen. So it's okay that we added around it. When we're adding non-integers, like if we're adding 2 pi or pi, something like that, then it would matter, possibly. Maybe it works out the same, maybe it doesn't. It just depends on the number combination. But with adding or subtracting 360, which is an integer, it doesn't matter. All right, then the last one is another domain given. So, again, if you do happen to reset, just be sure you change your mode back to degrees, since this one's in degrees. Y equals. Now, I'm not going to add this one. I'm going to keep this y1 and this over here y2. I'm not going to move anything over. You can if you want every time. You don't have to any times. It's up to you. So 7.2. Whoops. 0.2. And then 4 sine. Now again, if you can make it 1/5 look like that. If you can't, on your calculator, because it's older, put the 1/5 in its own set of parentheses. The x plus 10 has to be in its own set of parentheses, and I have to close again. So I open, 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 close, close, close. I have to close as many times as I open because I'm adding that plus 5. If you struggle with the parenthesis part of it, my suggestion would be subtract that 5 over and say that equals 2.2, and then don't put the 5 on the other side. Bring it over and clean it up a little bit. You can always do any kind of cleaning up you want before you put it in the calculator. But don't mess that up, because then everything's going to be wrong. Now, instead of trying to figure out my calculator, like what it looks like, I can go straight to the window, and I know that I only care about numbers between 0 and 720. So I can go straight to that and graph it. So there's 7.2, and there's the function. So I know I have at least one answer. And then I might have something else over there. I just don't know. So there's 1. X equals 156.835, and that's degrees. Second trace 5. Now, this is where, depending on kind of if you have a newer or older calculator, it's going to do some different things for you. The newer calculators don't require you to like have the point of intersection on your screen. My calculator that's a little bit older, if that point of intersection isn't on the screen, it's not going to find it for me. Enter, enter, enter. What mine does is it kicks it back to that other one. So that could mean a couple different things on my older calculator. Either it wasn't on the screen, or it's not there. If it's not on the screen, then that means it's bigger than 720. Therefore, we only have one answer. If your calculator found that, you would have got 723. Well, 723 is bigger than 720. So we know we only have that one answer. And that is it. So